So in this problem, we are taking a look at exponential decay and half-lives. So looking at the problem, we're talking about the amount of carbon-14 that is remaining inside of a dinosaur. We're talking about the half-life being 5,730 years. So after one half-life, if some object originally contained 100 grams, a half-life is going to be how much is left after that 5,730 years. So there's going to be then, for this question right here, how much remains of the first half-life is going to be 50 grams, because it's a half-life, half it's going to remain. So then after two half-lives, there's going to be 25 grams. For problem B, they want us to draw then a graph for this. So if we take a look at a graph, we know that we are starting off here with 100. And then after the first half-life, we are then down to 50 grams. After the second half-life, we are then at half of that, so we'll be at 25. Half of that then for the next one. And that trend will just keep continuing then as we can go on and make all of these next spots here. This is going to be a continuous graph because at any point you would be able to calculate the half-life. It does not have to be an integer number of half-lives. So the graph would look something like that. Problem C then wants us to write a statement here. But how much can remain after x half-lives? So we're going to be writing our equation here. So it also wants us to write a let statement. So this is defining our variable. So we are going to let x equal the number of years and y is going to equal the amount of carbon-14. So our equation then for this is going to be 100, or y equals 100, times a half-life to the x. For problem D, I'm going to clear away some of this here for you. For problem D, when we're looking at that one, we want to know what happens where x equals 0, and does this make sense? If we take another look at our graph, we can see right here in our graph that when x is 0, we have 100, and at that point that means that the decaying process has not started yet, so we're still going to be at 100 grams. And for the last problem here, the output of x equals -1, well, from our equation we had here, if it is 100 times x, or times rather 1/2 to the x, if we have that to the negative first, that is actually then going to equal 200 grams, since 1/2 to the negative first will equal 2. Now half-lives do not have to always be, or exponential decay rather, does not always have to deal with half-lives and carbon-14. Exponential decay can be talking about something like this. So a car was purchased for $2,000. It's decreasing in value at 15% per year for the last several years. And then we want to know what's it going to be worth after 5 years. So first of all, if we're talking about decay here, it's decreasing by 15%. That means at 100% it is going down by 15%, which means our percent, or our multiplier here that is going down is going to be 85% of the previous year. So our multiplier is going to be 85%, which is 0.85. So if we're starting off with the initial value of $20,000, our multiplier is 0.85. And again, we want to figure it out for 5 years. Our multiplier is to the fifth. So after 5 years, that same vehicle is going to be worth about $8,874.11.